All right, everyone, welcome to the week 1 live classroom. I hope you all are doing well. So in these live classrooms every week that I will do all the way through week 13, I will review the course content that we'll be covering for that week and also kind of go over any questions that you guys have. In previous semesters, I have also done office hours where I'd just be on my computer available to anyone who wanted to come and get help. I'm not doing that semester, but know that I do get notifications on my phone. So if you guys need to meet up, just shoot me an email or a text and we can find a time to meet up. So just to kind of get you guys started with a couple of things, I want to walk through a couple of the places where I put a bunch of important things in iLearn. Okay, if you guys haven't noticed yet, we're not using Canvas, probably like most of your other classes are. CIT 160 is one of the last ones to switch over just because of some of the programming stuff that we do. But feel free to stop me if at any time you guys have questions. Okay. So when you come in, this is what your screen looks like coming into our class. Usually I just like to click on content and kind of go from here. You can click on week 1 and see everything that week 1 has to offer. This overview page is the main thing that I want to show you guys right now. It has some information about me and the best way to reach me. There is this cool little like messaging feature inside of iLearn, which is great. You can send me messages like that, but I will only get those messages if I'm actually logged into iLearn. Okay, I'll get them once I log in, but for quicker communication, feel free to text or email me at either one of these. Okay. Also, this classroom that you've entered just now is where we will do all of our office hours and also all of our one-on-one appointments. Any questions about that, about best way to reach me, personal appointments, live classrooms, anything like that? Okay. This link right here is super important. I think it will probably be the most used link in the course. I have a bunch of videos that I've recorded for you all that will become unlocked as we go throughout the course. A lot of students end up having questions about a lot of the assignments on how to get started, asking for help, and so I just kind of like made a short little video for each assignment saying how I would start it. Not that you have to go that route, but these are here for your use. In addition to that, at the end of each chapter, there are programming exercises, and I've completed these ones right here for your use as well. Okay, and then the live classroom recordings, I'll just include links here as each week goes on in the course. Okay, and again, to get to this link, it was in the overview tab of iLearn. Okay, it was this one right here, live classroom recordings and assignment recordings. Okay, outside of that, I mean, just feel free to go through the syllabus and the rest of the course content that's introduced this week. I do have my late work policy right here that I would also encourage you to read. It is what I will be going off of for this semester. So it's pretty simple, fair in my opinion. Let me know if you don't think it's fair. But yeah, so I'd encourage you to review these as well. Any questions about any of this stuff? Okay. In that case, without any further ado, let's dive into chapter 1. Has anybody had a chance to read chapter 1 yet about computer hardware?
I've read partially.
Nice. Well, good job, Elena. So yeah, so there's quite a bit going on in chapter 1. This is a programming course, and the reason why we teach computer hardware going into this is because it's important to understand how computers function behind the code. And we'll go into this a little bit today, but the code that you write is classified as software. Okay, so the whole class will be writing software, and you'll run it in a browser, which is another piece of software there to run HTML and JavaScript code. But it's important to understand how hardware works and how hardware interacts with software, because it's a lot of what we have to worry about as programmers and as software developers. So again, feel free to stop me if you ever have any questions. But diving into this chapter, we start learning about semiconductors. Okay, now these are tiny parts of a computer, microscopic parts that are there to control the flow of electricity. Okay, there are 5 different types. There's a capacitor, which temporarily stores electricity, this guy right here, kind of like a little battery. There's a diode, which allows electricity to flow in only one direction. So it restricts it from one direction and it allows it to flow in a specified direction. There's an LED, which emits light, electricity when electricity is flowing through it. There's a resistor, which resists the flow of electricity, and so electricity won't be able to travel through this resistor, and that's generally used to protect the computer and other pieces of hardware inside the computer from electric surges. And then there's a transistor, which can be used to basically amplify or automate switches in a computer. Okay. Now, all of these things, as we discussed it a second ago, most of these semiconductors are microscopic, and they all kind of settle in nicely into what's called an integrated circuit. Okay. Now, there's a lot of different things going on here. We'll go over some more of these parts, but there are a load of semiconductors on here that control the flow of electricity to make sure that the computer is doing what you need it to when it needs to and is able to follow directions. Okay, but a circuit is composed of many, usually billions of semiconductors etched on a small piece of silicon. Sometimes this is called a computer chip. Okay, and so if you think about a computer chip, all it really is a billion switches. If you think about like light switches, when you turn on a light switch, all of a sudden you're allowing the flow of electricity to go to your light bulb, and then it lights up. Okay, a computer circuit is very similar. Okay, if you think on a microscopic scale, there's at the base of a computer, you're dealing with either true or false values. Okay, either the electricity is flowing or it's not. Okay, and that's what these semiconductors are used for, to control that flow of electricity. Any questions about semiconductors or the high level of an integrated circuit that we just talked about? Okay. So with that said, let's go over a couple of parts of the computer. Okay. So we have the power supply, generally a battery, or you just plug it into the wall. Okay. We have a keyboard and a mouse that are used for the user to interact with the computer, to provide input for the computer. We have the monitor, which provides output to the user. We have the motherboard, which is kind of like the hood of a car. Okay, all the components of a computer kind of settle in nicely on the motherboard to interact together. We have the bus. Okay, the bus. If you look at this integrated circuit, you see all these like little lines. Okay, and these are actually ways by which data and electricity can flow across this integrated circuit, and that's what the bus is there for. We have the BIOS, and this BIOS is used for starting up the computer. Okay, it has data which never leaves, and when the computer is in a turned off state, as soon as you turn it on, the BIOS is the first thing that gets run with instructions as to how you want to turn on your computer. Main memory, often referred to as RAM, is what is used to temporarily store data, and it's very important for executing tasks because all programs use some amount of memory on your computer. So one big difference between the main memory and the hard drive, for example, is that the main memory is what's considered volatile memory, okay, which means it erases without you telling it to. If it loses power or if you turn off your computer, it's not permanent. No data is stored in main memory in a permanent state. Okay, that would kind of defeat the purpose. It's data that's stored there is meant to be temporary. It's meant to be a little bit agile so that your computer can actually, utilize its resources to the best of its ability. Whereas the hard drive is there to save data somewhat definitively. Okay, so when you save something there, it'll stay there until you delete it or until something happens that forces it to be deleted. Okay, but the hard drive is there for permanent storage. Okay, CD or DVD drive, jump, thumb, or flash drive. Interesting tidbit about flash drives, you can actually use these to expand your main memory or your hard drive, as you guys probably know. The CPU is short for the central processing unit, and that's kind of where your computer does, the majority of its thinking, if you will. That's where all of the tasks are actually executed. When you give the computer a command, everything runs through the CPU to see what has to happen with that command, how it'll be executed. And then there's the cache, which also works as as a temporary form of memory to help with running programs. Okay, so I just threw a lot at you guys. Do you have any questions about any one of these? You're probably familiar with several of them. Okay, sounds good. All right, moving along, data sizes. Okay, this is more just here for your reference. It may or may not end up on a test at some point. I will never ask you to like list these out in order, but they are here for just for you. It's important to understand how the computer uses data and how it actually stores data. So if you remember when I was talking about the light switches and how it's like the very baseline of a computer, it stores things in a true or false value. Okay, that could be considered a bit, a binary digit, where it's either a 0 or a 1. It's either false or true. Okay, and so at the very baseline of everything, whether it's data in a Microsoft Word document or a program that we write, or this conversation over Zoom, like there's all these different types of data, but at the very baseline, it's all just a bunch of true or false values. Okay, and thrown together with millions of other true and false values, you can actually get a web page or a video conversation or a song. Okay, but all this data, it isn't stored, you know, like with like some video actually on the hard drive or a song, but it's breaks down into bits, into true or false values. Okay, a nibble is 4 bits joined together. That's just kind of a slang. It was probably once a slang, but it's an official term right now because a byte is 8 bits. And so they're like, oh, what's between a bit and a byte? It's a nibble, because it's kind of funny. A byte is 8 bits. Very common if you've ever seen like an IP address. It's 4 bytes joined together. Okay, 8-bit sections, and there's 32 bits total for an IPv4 address. There's a kilobyte, and a megabyte, gigabyte, terabyte, petabyte, and exabyte. Okay, keeps on getting bigger and bigger, and I feel like the more we get into this technological age, the more we use these bigger things. Okay, just a few years ago, it was never even heard of that we would need something bigger than a gigabyte, and now most computers have at least a terabyte of storage. You know, if you spend a few $100 on a computer, and you know things are constantly evolving. So, any questions about data sizes? Okay, so thinking back to the CPU, I mentioned that the CPU is the central processing unit, and it's where our computer actually executes tasks. Okay, in thinking about that, there are lots of different types of CPUs. Okay, when you are reading about a computer or you're looking to purchase a computer, you see, you know, it'll mention maybe like screen size for a laptop and how much RAM it has, how big the hard drive is, and then it'll say like, you know, a 2.7 gigahertz CPU or something like that. Okay, and that's because the CPU is measured by how much it can actually execute. Okay, which is directly correspondent to the clock speed within the CPU. So really, all a CPU is something to monitor tasks that are being executed within a computer. Okay, and it does this by having a clock speed. Okay, and that is a small electrical circuit that repeatedly produces an electric signal. Okay, and so, for example, every second, a CPU will be able to execute X thousand number of tasks. Okay, and these are little things. It could be like transferring a bit or a byte of data across the bus or something like that, or actually calculating math. But it takes a lot of these pulses to do anything that we can actually recognize. Okay, and so a single core on a CPU is designed to complete one instruction at the end of each pulse. Okay, and so a hertz is a unit of frequency equal to 1 cycle per second. A megahertz is a million per second, and a gigahertz is a billion cycles per second. So when you see that a computer has a CPU of like 2.7 gigahertz, that's actually pretty intense because it can execute 2.7 billion cycles per second. Okay, and then kind of a fun question here. It says, how many instructions per second would a 2.5 gigahertz quad core CPU be able to execute? Any guesses out there from you guys?
Is it like 10 billion? Because it's quad?
Yeah, Yep, that's exactly it. So when you have multiple cores in a CPU, each one of those cores functions independently of the others. Each one of those cores will have that ability to execute tasks at that clock speed, whatever its capacity is. In this case, we have a 2.5 gigahertz CPU, but like you said, Elena, it's a quad core, so it has 4 of those CPUs working at the same time, and so in theory, it could execute 1 billion cycles per second. Okay, which in my mind is pretty intense. Um, but one question that I frequently get about clock speed is this the same thing as like how much your computer will be able to perform? Okay, and it's important to recognize that clock speed is the rate at which it can like send out tasks, not how much it can do. And here's the difference. I have, let's say I'm moving. Okay, I'm going to move it in a couple weeks. This is a fitting example. Okay, so let's say I have a couple of guys here. I have a moving truck in my driveway, and I have 3 guys who are helping me move everything from my house. Okay, and let's say each of us, it takes us 2 minutes. Okay, to go from the truck into the house to grab a box and come back out. Okay, that doesn't really affect, it'll take me that same amount of time if I'm grabbing a lamp or a box of books, even though a box of books will be a lot heavier than a lamp. Okay. And then all of us will be, going in. We'll still take like 2 minutes because we have to like walk over, grab something, and come back. Okay. And a CPU, it's a similar thing. Okay. It doesn't really affect how much can happen. That's more like what main memory and the cache are used for, to be able to utilize data, to save data temporarily. And so it's important to have a computer with a high gigahertz rating, and it's also important to have a computer with a lot of main memory and different things like that. They kind of coincide with each other because they do different things. Okay, any questions about clock speed? Okay. So common classes of computers. We have a micro or personal computer. These are designed to be used by a single person at a time. Could be classified as the laptop I'm using for this class right now, a desktop computer, a tablet, smartphone. These are all personal computers or microcomputers. Okay. Then we have a workstation, which is a powerful computer designed also to be used by a single person at a time, but is used to perform heavy tasks, anything with heavy math like engineering or scientific stuff, medical tasks. Some examples of these would be just designing airplane parts. I've had to develop code for projects using virtual machines. And so a workstation like this would be able to, support several virtual machines at a time. So just a really powerful computer. And then we have a mainframe, which is also a very powerful computer, much more powerful than your regular workstation. That's designed to be used by many people. Okay, and these are relatively common in scientific areas, used to perform heavy tasks with multiple people trying to collaborate and using them for the same purpose. In my line of work, I've never used a mainframe computer. I feel like with the way technology is going, it's also more and more accessible to get really powerful personal computers or workstations. And so, yeah. Any questions about common classes of computers? Okay. So let's go into software a little bit. So computer hardware, we already talked about a little bit. Okay, the bus, cache, main memory, hard drive, CD player, all this is hardware inside of a computer. Software is the way that hardware actually does something. Okay, so right here I wrote computer hardware won't do anything without some instruction, and these instructions are written by programmers or software developers who write software. Okay, there are several different types of software. First is an application. It's a computer software that someone uses to accomplish a specific task. Okay, so a couple of applications that I have open on my computer right now are Google Chrome, Zoom for this meeting. I have a couple of text editors open for work, but any application is just like something that you can like click on your computer, like Microsoft Word, or if you have a game downloaded on your computer. All these are different types of applications. Operating systems are special pieces of software that manage the hardware in a computer. Okay, so Google Chrome wouldn't really work very well if I didn't have an operating system. Okay, neither would my text editors, neither would Zoom. You have to have an operating system because without the operating system, your code has no way to interact with the hardware of a machine. Thankfully, in this class, we will never have to worry about interacting with hardware in our computers. Okay, that'd be pretty intense. So thankfully, we won't have to worry about that. Okay, our software runs happily within an operating system. Okay, independently of hardware, doesn't have to worry about it. The operating system kind of acts as an intermediary between the hardware and common applications that people use to execute tasks. Okay. So right here I wrote that the operating system isolates the applications from the hardware. That is completely true. And because of that, applications don't have to interact directly with the hardware. There are applications that can manipulate the hardware, but it's always through a different type of operating system, like window, if you will, generally called a kernel. So, any questions about software? Okay. All right, so let's go into character data. So earlier I talked about the binary digits, okay, the bits that are either zeros or ones, resembling true or false values. Now, everything in a computer's memory is stored as a number or a set of numbers, okay? The American Standard Code for Information Interchange, or ASCII, is a coding system, basically a table of codes with 128 rows that assigns a number to each English letter and common punctuation symbol. Okay, so my name right here, Birch, these are the numeric codes to go along with each of the letters in my name. Okay, and you'll notice that a capital B right here is a completely different code than the lowercase value. Okay, and so every single letter that we see behind it, there was like a code somewhere that was written in code to be able to pull that value up. With common programming languages, we don't really have to worry about doing these code conversions very often. It's just how they were written, and that's how the computer actually stores data. And behind this, we would eventually convert this into a binary value or a set of binary values to be able to store this as well. Okay. Then there's also Unicode, which is a very large coding system, much larger than this one. So you'll notice the American Standard Code for Information Interchange is just for the American letters and punctuation symbols. Unicode has everything. Okay, it has all the accents in Portuguese and in Spanish, Greek, Hebrew, Arabic, Tagalog, Chinese, all of it. Okay, and that's what Unicode is. So, any questions about character data or either one of these things? Okay. And again, for your reference, in this class, we touch on this in week 1. You'll see it on your exam in week 5. You'll also see a couple questions on your final exam in week 14. But outside of that, you won't really have to worry about this. It's important to understand how these things work, but once we dive into it, you'll just have your text editor and you'll be writing code. And so, but yeah, it is important to understand how these things work. All right, so let's talk about an execution example. Let's say the user clicks on a Microsoft Word document. Let's go over everything that would actually happen. So first of all, the operating system commands the hard drive to copy the Microsoft Word application into main memory. So for the computer to even utilize Microsoft Word, it has to be in an accessible state. It can't just be buried deep within the hard drive, which is where it's stored, okay, in that more permanent memory. But the operating system will actually have to copy that over into main memory so that it can use it. Then the hard drive copies Microsoft Word over a bus into main memory, okay? So the operating system makes the command, and then it copies over a bus into main memory, okay? And then it ends up there. After Microsoft Word is in main memory, which again is generally classified as RAM, the operating system executes Microsoft Word and sends a command to Word telling it to open the document that the user double-clicked. Okay, simple enough. Then Word requests the operating system to read the document from the hard drive and to place it in main memory. Okay, so we just transferred Word over to main memory. It's now accessible. We'll open it up, and now Word's like, oh wait, this was opened with like a specific file in mind. Okay, so it then requests to the operating system, okay, find this file, and the operating system copies this file again over the bus into main memory so that it can actually be utilized. Okay, and the hard drive copies the document over the bus into main memory, and then for every character in the document, it does two things. Microsoft Word reads the character's Unicode number from main memory and requests the operating system to draw that character in a window. Then the operating system finds the Unicode number and its corresponding symbol in a table and draws the symbol in the window for the user to see. Okay, so you talk about clock speeds and how we're like talking about the billions of tasks that a CPU can execute, right? But this is actually a pretty high-level version of what our computer does when a user clicks on a document. Okay, there's a lot that goes on behind the scenes that 99% of people are never even going to have to worry about. Okay, and so this is how a lot of these pieces will function together to execute a simple task like opening a Microsoft Word document. Okay. Any questions about this or any one of these parts of the computer that are working here?
You mentioned the difference between a Unicode and the ASCII code.
Yeah.
When do you know which program uses which code?
So it's a matter of performance because the Unicode character set of data has all of the ones that the ASCII one has. And so anytime a program can, it will try to use just the ASCII set because it's a lot less data to worry about. Okay, but anytime there's data, any special characters, like we were talking about, any one of those different languages or special accents that the English language doesn't have, then it's Unicode because the other one doesn't have it. Does that kind of make sense?
So if it was a program written in China, it would use Unicode rather than your ASCII code because your code, depending on the language it was coded in.
Yes. Yep. And with that, so most other languages are going to have to use Unicode, but a lot of applications written in the United States also use it because most applications support multiple languages. But where it ends up being worried about the most is inside of databases. As far as applications go, most applications have a database storing data, and that's where that data is stored. And most databases use Unicode because they know that there are frequently multiple languages being used in applications. So, yeah, does that answer your question, Spencer?
Yeah, thank you, sir.
Okay, yeah, you're welcome. Good question. Any other questions? Okay, so that was it for me running through chapter 1. Again, here on the homepage, as soon as you log into iLearn, every week I'm going to post one of these announcements, kind of giving you a calendar of everything going on. Just so you guys know, this is my first time trying a live classroom around lunchtime. I've done it in the evenings previously to this, and it didn't really seem to be the best time for a lot of people, and so just trying something different. But week 1 looks really big and overwhelming just because kind of want you to know what is available to you, not that all of this stuff is due. Okay, if you look at your actual deliverables, things that you actually have to submit, there's a syllabus quiz, and the information survey you don't have to do. Getting to know you, this discussion you do have to do, and then the chapter 1 review questions and self-assessment survey. Okay, those are the actual things that you have to submit. Okay, the self-assessment survey will ask you if you viewed the videos about computer hardware and if you read the chapter and different things like that. But there really isn't that much to submit, so don't get too overwhelmed by this. But I will provide something like this for you every week, just so you guys have, as soon as you come on iLearn, you'll see this and you're like, oh, okay, that's what we have to worry about this week. And then below these, I'll have a spiritual message of the week that I'd love for you to read. And along with that, I'll also be offering extra credit for a discussion associated with that message. Okay, so Here's the extra credit discussion. It'll be at the top of each discussion for every week. And it just talks about that message and asks some questions for you to think about, and we can have a little spiritual discussion going on every week. So any questions about iLearn or the class in general, things to expect in the class?
I have a question. Can you hear me?
Go ahead, Emily. Yeah, I can hear you.
Okay. So will we put into groups? Is that what the team formation survey was for?
It is what it was for. The reason why I said you don't have to take it is because we're not going to be in groups this semester. Okay. I didn't take it out in time, but we aren't going to be in groups. Okay. The way that it's going to work, every week, starting in week 2, you will have a specific programming assignment. Okay. And you will be required to post that assignment onto a discussion board on Wednesday. Whatever you came up with, whether it's finished or not, you'll post it on Wednesday. And then you'll have 2 days to respond to other people's posts and make your code as best as you can. And then you'll have your final code submission on Friday. And then you'll be graded for your participation in that discussion board and graded on your final code submission. Okay. But so your group, in essence, is the entire class. Okay. So that will be your group. So,
okay, thank you.
Yeah, good question, Emily. My daughter's name, one of my daughters is named Emily, by the way.
It's a common name.
I suppose it is. All right. Any other questions?
I had a question.
Yeah, go for it, Spencer.
So I just noticed that there's a discussion board that's extra credit.
Yeah.
Is that something you typically do every week? You give some kind of extra credit?
Yes. So if we go back to our homepage here, on Monday morning, I will post an announcement for the week that has the schedule and then a spiritual message. Okay. After reading the spiritual message, if you go over to the discussions tab, the first item in that week, for whatever week we're in, will be the extra credit discussion that talks about, that just has questions related to the spiritual message that I provided in the announcements. Okay, and so to get the extra credit every week, it's just 1 point offered, which is about 1/3 to 1/4 of your weekly code submissions. So over the course of the semester, it's worth several assignments if you do it every week. But all I'm asking is that you just kind of share your thoughts. You don't have to answer these questions. Just share your thoughts about the spiritual message or anything, and maybe participate, talk with some of your peers in there, and that's it. So.
Perfect. Thank you so much.
Yeah, you're welcome. I would encourage you to do this. A lot of students come like week 11, 12, and 13. They're like, what can I do for extra credit? And I'm like, well, you've had like 10 weeks to work on it. Because the class does kind of pick up. It takes a few weeks for it to pick up, but around week 5, it really picks up. We'll be going into math and converting like algebraic expressions into JavaScript. And so I would encourage you to take advantage of this as much as possible. Okay. So plus I love our spiritual discussions. It's like my favorite part of the class. Good question. Any other questions?
So how hard is this class for those people who know nothing about JavaScript?
Hard is it's a relative thing. My first experience with programming was this class just a few years ago, and it was hard. It is new. It's a new way of thinking. You think about learning a new language, whether it's English or German. It takes a lot of work to learn a new language, and it takes a lot of work to learn a programming language. Okay, so I wouldn't get overwhelmed, but at the same time, I wouldn't underestimate the class. It's doable, Elena. It's very doable, and if you put in the effort, you'll get it. Okay, it'll start clicking for people at different times, but as long as you're working hard and putting forth the necessary effort, you're going to do it. So don't be stressed about it thinking, oh man, I'm not going to be able to do it, because you can do it. Okay, but definitely, like, the more you practice, the better. This class is a 3-credit class, and so it's recommended that you spend 9 to 12 hours a week in this class. And I realize that that's not always doable. Okay, but try to code as much as you can. The videos that I have, where was that? If I go back to content, I want everyone to bookmark this thing because it's really important. So this link right here, live classroom recordings and assignment recordings. So if I come here, like I start off each assignment, you know, like how I would do it. And then I have a second video that will be released a week later for you to review for how I finished that assignment. Okay. And so this is a really huge help too. You know, participating in the live classrooms helps because you can ask questions. And then watching these videos, you know, as each assignment comes up, just like check it out, see how I would start it. And then when the week's over, feel free to review the walkthrough of the assignment to see how I finished it. And then in addition to that, these are also helpful as well because they oftentimes cover a lot of the same principles that we're covering and that will be needed in the actual assignment. So, and with that, I would just leave this video going, like have it open on your screen while you have your text editor opening, having your text editor open, and you're like trying to like code along with these videos. So,
I have a question.
yeah, go for it.
So for the assignments for each, I don't know, will they be exactly like one correct answer, or will we each kind of submit our own different kind of code, you know?
Yeah, so there will be many ways to do most of the assignments. Okay,
That's what
some
I
of them,
thought, yeah.
yeah, some of them will be pretty simple, especially starting off. They'll be pretty simple. But once we get a few weeks into the course, you'll see a huge variance in the submissions, like in the discussion board with your peers, and that's not always a bad thing, you know. And you'll even see sometimes I start off an assignment in one way and then I end it in a different way. I'm like, you know what, I decided to change this up and I'm going to do it a little differently. Imagine it if I was going to like walk to the corner of my yard. You know, I could go to like the left and then to the right, or to the right and then the left. Like there's more than one way to get there, and it's the same thing with your assignments.
Okay, thank you.
Yeah, you're welcome. Good questions.
Question. So I probably need to read more through the class material, but how many languages are we learning or going over this semester?
Technically 2. So if I come into here, so week 1, we're covering computer hardware. Okay, so no programming languages this week. Week 2, we have a simple programming exercise, but you don't really have to code anything. Even though it's technically in JavaScript, you don't really have to code anything. Week 3 is about HTML. Okay, and I don't want you to get overwhelmed. You don't have to worry about this right now, but we're going to start learning HTML in week 3. And the reason why is because HTML will provide us a way to run our code in a very visual way. And so all of our code, we're actually just going to run in the browser. Okay, browsers run HTML code really easily. A lot of web pages you'll see have like an ending of .html, and that's just an HTML file that's being run on your browser, in your browser. Okay, so week 3 we cover HTML basics, and then week 4 we dive into JavaScript basics. The rest of the semester is focused on JavaScript. Okay, so we have one week to kind of learn about HTML and how we're going to run our code, and then the rest of the semester is all about JavaScript.
Awesome, thank you.
So yeah, technically HTML isn't a programming language, even though it is like a coding language, but this is a JavaScript class. So
okay.
All right, good questions, you guys. Any other questions? Okay, well, again, I'm here for you guys, so feel free to email me or text me if you have any questions. Again, the best way to reach me isn't with this fancy little messaging thing in iLearn, but it's either via email or just send me a text on my cell, okay? Because I like to respond as quickly as possible. I know how stressful it can be in an online class trying to get stuff done and you're stuck and your teacher doesn't respond for a couple of days. So I recognize that. So feel free to email me anytime and I'll get back to you as soon as I can. And I'm also happy to meet up with you guys one-on-one if you need. So, but if you guys don't have any other questions, I think I'll let you guys go.
I have one more.
Oh, yeah, go for it, Emily.
So we don't have a TA for this class. I haven't had online classes before, so I'm not sure if they're TAs.
You do not have a TA. However, I have a link right here to a tutoring service provided by BYU Idaho. This is an incredible thing another thing that most students don't do until like week 7 or 8 when they're like, oh man, I need help.
Mhm.
So there's nothing shameful about getting a tutor, especially in an online class. It's tough.
Mhm.
So that link was in the overview tab or in the overview page of iLearn. And you basically just say like what class you're in, say when you're available, and a tutor will get in touch with you to set up an appointment. And you just meet up one-on-one. You can bring your assignments, ask your questions. And that's a free service that you guys can access.
All right, thank you.
Yeah, you're welcome. And then with that, one of my students last semester was like, so I feel like my tutor is able to give me the answers, but I have no idea why the answers are the way that they are. So please feel free to email me if you have questions. You guys can email me screenshots, be like, hey, this isn't working, email me code, and I can help you. I can help walk you through some stuff too. So, all right. Any other questions? All right. Well, you guys, I appreciate you coming, and I look forward to a good week with you guys. Okay.
Thank you.
Thank
All right.
you.
Thank you, guys. Have a good week.
Thank you.
Thank you. Bye-bye, guys.
Bye.